Good morning, everyone. My name is Chris Donnell. I'm the Manager of Support Services here at Altranstech. I'm happy to have the opportunity to introduce this morning's webcast on critical to quality characteristics for quality assurance programs. This presentation today is going to be done by Dave Ronzani and Jim Donnell. Dave is the Director of Railcar Regulatory Compliance here at Altranstech. Dave's worked in the rail industry for over 42 years and has been with Altranstech for 8 years. Dave currently chairs the AAR Task Force for Non-Destructive Testing and has his ASNT NDT Level 3 in 8 different entities methods and is a Senior AWS CWI. Jim is the Vice President of Technical Services here at Altranstech. He's worked in the rail industry for over 33 years and has been with Altranstech for over 21 years. He has his NDT Level 3 in 8 different NDT methods and is a Senior AWS CWI as well. Before we begin, I want to go over a few housekeeping items. Altranstech is one of North America's largest railcar management consulting companies. We provide fleet management and technical services to a variety of railcar owners, shippers, as well as rail repair facilities. We're going to structure this presentation with approximately 45 minutes of content, followed by 15 minutes of question and answer. If you have any questions, please feel free to submit them in the question pane, which should be on the right-hand side of your GoToWebinar window. We'll work through the questions through the Q&A period. Also, please take a moment after the webinar. There will be a survey that will be sent out. Fill us in, let us know how everything went. And we're also going to be asking for any possible ideas for upcoming webinars that you feel would be beneficial to you. With that being said, thank you everyone for joining us, and I'm happy to introduce Dave Ronzani and Jim Donnell.
Good morning, everybody. This is Dave Ronzani. Before we get into the actual requirements of CTQ, just a couple of disclaimers about what we're going to talk about today. So, this presentation is a discussion on critical to quality characteristics and quality assurance guidelines. So there are several ways to address CTQ requirements. What we're going to talk about today is one way to address these requirements, but what your company does and how this applies to your facility depends on a few things like your components and processes, federal regulations, including FRA and TC, AAR requirements, and your own quality program. So critical to quality, CTQ, as it relates to quality worldwide, is a generally common term. But if you do some research on critical to quality information, you may find a lot of information relating to customer satisfaction and voice of the customer. We're not going to talk so much about that today. You may not find specific information about our discussion as it's related to M1003 certified facilities and how CTQ relates to incoming inspection. So we're using that term, critical to quality, CTQ. A lot of information out there on the web. Might not look exactly like what we're going to talk about today, but we think we put together some good information related to AAR certified facilities. So, and this is a quote, critical to quality for manufacturing. CTQs are usually defined during the design and development phase. A CTQ is a characteristic that has a direct effect on whether the overall process or product is perceived by the customer to be of acceptable quality, or the process or product's fit, form, function, or safety. The identification of specific measurable CTQs is critical in the planning and commercialization of goods and services. Now, don't forget when we use the term customer, that might be your external customer, it might be your internal customer. So keep an open mind to that. It doesn't necessarily always mean the end user. So another quote, critical to quality about facilities. A CTQ is a product or service characteristic that must be met to satisfy a specification or requirement. And to me, that kind of hits home because I think that's really going to apply on how we're going to address CTQs for AAR certified facilities. All right, so where does the term come from, at least for us? So if you look at, and I think we've got a little bit of a typo there, but we're really talking about M1003 definitions. I see we have M1002 C3 Chapter 1 up there, but we're talking about M1003 definitions, characteristic. So the definition of characteristic is a unique attribute essential or critical to quality. So at this point, this is the only place where M1003 utilizes the term critical to quality. And it might not be familiar to a lot of us, but the requirements that are currently in M1003 and that have been there for a while really address what we're going to talk about today. So maybe the term critical to quality might be new to some of you, but the process itself should not be. And let's talk a little bit more about that. So in M1003 2.5, production inspection and test planning, we use the term characteristics. And the reason I've got that underlined and I had the definition of characteristic up there before is because, so now characteristic is defined as critical to quality, right? We saw that from the previous slide. So now where we use the term characteristics in M1003, critical to quality is going to apply. So 2.5.2.2, identify the characteristics to be inspected, examined, and tested at each point and specify acceptance criteria to be used. That's not new, right? That's been there for a while. Your programs should really address that anyhow. We may need to address that in more depth for a lot of incoming inspection procedures, but that's up to your own quality program. Right, and then a couple other paragraphs about 2.5 as well. So how does that tie into what we're talking about today? And today we're really focusing on critical to quality characteristics for incoming inspection. So if you look at 2.10 in M1003, incoming inspection, 2.10.1, inspect, test, and identify incoming items as required by the inspection and test plans. Well, it doesn't use the term characteristic there. It doesn't use the term critical to quality there, but it says that for incoming inspection, I have to follow my inspection and test plan. Back to 2.5, my inspection and test plan does say I have to identify characteristics and acceptance criteria. So those are two key issues that I want you to keep in mind as we go through our presentation today. So these requirements are already in M1003. We may be looking at them in a different light today as we apply the term critical to quality or CTQ. So identifying key characteristics, what are we going to do with that? So are you doing that already? Do you need to add more information to your program? That might be some questions you may need to ask yourself, right? So the key characteristics will be the result of your customer needs and requirements, the criticality of the component, design specification, or regulatory requirements. So identifying key characteristics is the certified facility's responsibility. That's what was already written in M1003. But it will be essential to work with customers and suppliers to implement a proper quality program. So you may want to work with your customers, and are those external customers or internal customers? What are their needs and requirements? And of course, working backwards then through your processes to your supplier in identifying what those key characteristics will be. So examples of key characteristics for fasteners. And we're using fasteners as an example because it seems like an easy issue, and probably all certified facilities to some degree are going to receive fasteners. So some of the key characteristics for fasteners might be the material test report. Now, I know that in itself is not actually an attribute of the physical fastener, but the material test report is going to identify the material grade and the tensile strength, for example. Those two characteristics may be key for the type of fastener that you're receiving. Simply conformance to a standard. Am I purchasing the right fastener grade and material as specified in Appendix M from ASTM A193, for example? Am I going to, is the diameter and the overall length a key characteristic? Is the manufacturer mark and grade stamp a key characteristic? Is the thread pitch diameter a key characteristic? And the same thing with surface quality and more. These are just some examples that as a certified facility, you should identify and then determine, am I going to inspect for each of those key characteristics, or is my supplier, or are we both going to inspect for that? And we'll talk a little bit more about that in upcoming slides. So another example is a safety valve. A little bit trickier maybe, because there's certainly a lot of components to a safety valve. There's going to be key characteristics that the safety valve manufacturer may have for their suppliers, but those may not be key characteristics directly for an AAR certified facility. So as an AAR certified tank car facility, for example, if I'm receiving a safety valve, I probably most certainly want the certificate of test. Now again, the certificate of test itself is not a key characteristic of the component, but it contains information about key characteristics like the start to discharge pressure and the vapor tight pressure. I might be very concerned about the tag information, the serial number, seal wire, etc. Other documentation related to my QA program, my customers' needs, regulatory requirements, that sort of thing. So again, you may not yourself as an AAR certified tank car facility check all key components from a safety valve, but you're going to want to verify that your supplier is checking those key components and then maybe giving you some documented verification of that. That's why I use the safety valve as an example, because I think many or all of us are familiar with the safety valve certificate of test. That's a common piece of documentation that comes with a safety valve. Going forward, you may need additional information from your suppliers that are similar certificates for other materials or other components. We may or may not be doing that today, but moving forward, that may be something you want to consider as part of your quality program. And also we have material test reports, or MTRs, sometimes called mill test report. These identify the chemical and mechanical properties of a material. When are they required? Is the facility required to obtain a copy? So the first thing that comes to mind for me typically is tank insert material. If I purchase a piece of material for a tank insert, I probably should have the material test report. I should make sure that it's the right material. You could take it to the degree of confirming that each chemical and each mechanical property identified on the material test report meets the material standard requirement, be it A516 or TC128, for example. And is the facility required to obtain a copy? Well, if I'm putting a tank insert, a piece of material into a tank, then yes, that copy would be required. So just as an example for tank insert material, but material test reports could apply for other materials that you buy as well. And this is just an example of a material test report. This happens to be for a heavy hex nut, right? ASTM A194, if you can, the print's a little small, if you can read that material specification. But this just gives you an idea of what's on a material test report. And in this particular case, it's listing the heat number for identification, hardness of the material, and the chemical analysis of that particular batch of material. All those things may or may not be important for the particular material that you're receiving, but it's up to you as a certified facility to determine that. Because, again, back to M1003 2.5, Production Inspection and Test Plan, it says that you're going to identify key characteristics. Characteristics means critical to quality, and acceptance criteria. We'll get a little bit more onto that acceptance criteria coming up as well. So key characteristics should be verified to ensure compliance to, and these are just some examples, regulatory requirements, customer requirements, your own internal requirements, including what's in your quality program or other procedures or requirements, industry standards or specifications, AAR requirements, for example, and then simply design requirements of the material item or component that you're receiving, right? And there could be more. These are just some examples, but again, that's it's up for you. It's up to you as the facility to determine which characteristics are key for the materials that you're receiving. So who has the responsibility to verify compliance of those key characteristics? Well, according to M1003, it's the certified facility. And certainly that's true. But that certified facility may want to push a lot of those key characteristic compliance requirements back to the supplier. So this is where it's important for you to work with your supplier, provide the supplier enough information about what you want, what you're purchasing, what the requirements are, be it AAR requirements or an ASTM standard or your own requirements. And from my own experience, what I see for some certified facilities, it's order a part, tell the supplier, hey, I want 10 of item A and 100 of item B, and send me what you have. You're the expert. You're the supplier. Well, in some cases that may be true, but it is the facility's responsibility to ensure the supplier has the proper information of what the requirements are for the component or material that you're purchasing, and then of course that they have their own quality program and are confirming their own critical to quality requirements from their own quality program. Okay, so who verifies which characteristics? That depends on your quality program, and it depends on your supplier certification program. If I've determined that there's X amount of characteristics for a certain component, some of those I may be verifying at incoming inspection, and other characteristics I may be pushing that back to the supplier again, confirming that the supplier is going to inspect certain characteristics with stated acceptance criteria, so that when I receive that material, maybe all I'm going to do is some other things like a visual inspection, some dimensional inspection, and then verification of the documentation or certification that the supplier sent me. And so I'll go back to what we had earlier on the safety valve. So I receive a safety valve from a supplier. I'm going to inspect certain characteristics. Certainly I'm going to look at it visually to determine if there's any obvious defects. And your program or your incoming procedure may want to elaborate on that. But I'm also going to confirm that I've got a certificate of test for that particular safety valve and that the start to discharge pressure and the vapor tight pressure are within the correct parameters. I may not put that safety valve on a bench and verify it myself, although you could if you wanted to, but at the very least, I'm going to use that documentation from the supplier. So I'm relying on the supplier to verify key characteristics that maybe I determined, or maybe I determined those with the help of my supplier, or in the case of a start to discharge or vapor tight pressure, that's already been determined by, the acceptance criteria has already been determined by AAR C3 Appendix D, for example. So inspection protocols should be established for incoming materials. How are we going to handle all the different materials and components and items that we receive? So this typically could be a type of incoming audit of the material or component, some sort of sampling plan, for example. This can also be based on the results of the supplier certification process along with the supplier's performance records. So if I've vetted my supplier properly and I've determined that their quality program is robust and I'm confident in what they're going to be providing me, then I'm going to apply my own incoming inspection program accordingly. If I have a supplier that I don't have a high level of confidence in, but maybe I need to use that supplier anyhow, I may be doing more incoming inspection or checking more key characteristics, right? These are all things that you have to determine from your own quality program. Verification of supply documentation. Okay, we talked about things like material test reports and certificates of test for safety valves, etc. I may determine an inspection sample size, and I may use something that's industry standard. I may have to determine my own inspection sample size, and I may use, again, a sample size that's based on the reliability level and my confidence level of that particular supplier that I'm using, et cetera. Again, these are just some examples that you can review to utilize and analyze your own quality program. So the level of rigor that I apply at incoming inspection, for example, it can be based on the criticality of the component. Is it, a screw for a jacket patch, or is it a material insert, a tank insert? Is it a safety valve? Is it other critical components? Supplier past performance, my confidence level on that particular supplier, and of course, your own quality program requirements, what you have written into your QA manual and your QA program. So we talk a little bit about acceptance criteria, and a lot of you may recognize this. This is out of 49 CFR 179.7, the Quality Assurance Program. But you see that for tank car facilities, paragraph 5, a description of the manufacturing, repair, inspection, testing, and qualification or maintenance program, including the acceptance criteria, so that inspector can identify the characteristics of the tank car and the elements to inspect, examine, and test at each point. So I think I mentioned earlier that we're talking about really incoming inspection today, but because the tie-in with critical to quality coming into the definition of characteristic. Characteristic is a term used in your production inspection and test plan requirement. We're talking about incoming inspection today, but in reality, the same thought process applies throughout your plan. So acceptance criteria, and I'm using fastener for an example because simply it's easy to use. It's something I think maybe everybody sees and understands. There's all sorts of things that might be a key characteristic, and then if I have a key characteristic, what is the acceptance criteria? Well, I have the length or nominal length of a bolt, for example. Well, if I determine that that's a key characteristic, what's the acceptance criteria? Well, you're probably going to go back, instead of making that up yourself, you're probably going to go back to the standard for that particular bolt, you know, ASTM A193, for example. And so you can find those tolerances for certain characteristics that you identify as key, and then that's what you're going to want to check against. Now you see in the picture on the right, we have an example of a thread gauge for a bolt. And does that mean that if I determine that pitch diameter is a key characteristic of a fastener, which my opinion is that it would be, does that mean that I have to use a gauge on every fastener that I receive? I suppose you could. I don't find that common in the industry. To me, what comes to mind is that I really want to make sure that my supplier and their quality program are using gauges accordingly, and then I want some certification or documentation to that as I receive particular lots of material. And I may want to have thread gauges on hand to do a sample size for specific fasteners. Again, those are just examples. You have to decide for yourself as the certified facility what are the key characteristics and how you're going to address them, either directly through your incoming inspection process or by putting that responsibility back onto your supplier. And again, a little bit more about acceptance criteria, and this is somewhat of visual acceptance criteria along with gauging. So if you see the images on the right, you see a ring gauge and plug gauge. Those are not uncommon in facilities that I've been to, and so inspecting gauging the threads on a plug or gauging the threads in a valve might be determined as a key characteristic. And so who is going to evaluate that key characteristic? Your inspectors for incoming inspection, or your suppliers, or a combination of both. But again, back to acceptance criteria, the facility is required by M1003 to identify the acceptance criteria. That doesn't mean that you have to make up the acceptance criteria. You may get that from other standards. You may get it directly from your supplier or from your own quality requirements. So acceptance criteria can be partially based on risk assessment. And risk assessment has three basic components: risk identification, risk analysis, and then a risk plan. So as you're putting your quality program together with CTQs in mind, the criticality of the component that you're inspecting will probably carry some weight on what your acceptance criteria is or what your plan is going to be. For something more critical that is part of the containment package for a hazardous material, for example, is going to be much more important than a screw that's going to hold on a jacket patch, for example. But again, that's up to the facility to determine and decide the criteria. So the severity of a nonconformance can range from minimal to severe, as illustrated, in the following example. So depending on the component or item that I'm receiving, some level of tolerance is applicable, where I might have a minimal problem. It might be something that's a minor inconvenience. It could be something where a product is not meeting a standard, or the product is not meeting the customer's requirements. Or it could be something that is a safety risk to the public. So all those things may come into play when you're deciding what your key characteristics are, what your acceptance criteria is, and then what you're going to do if you do identify non-conforming items or materials. So what CTQ means in terms of a quality program implementation could involve these different aspects. Drawings of your components. You may find dimensions and tolerances there that you want to identify as CTQ. specifications that already provide criteria for you, tolerances in general, no matter where they come from, the types of components that is being inspected, and that could be assemblies or sub-assemblies, for example. You may have different CTQs related to different manufacturing processes, packaging or shipping. So even to the point of receiving a material that's properly packaged and shipped so that damage doesn't occur, for example. And then purchasing controls. Again, to me, in my opinion, identifying those characteristics with your supplier, having purchase orders that are clear and specific to your expectation for the material that you're receiving can be an important part of your program, and ultimately implementing a good way to verify key characteristics. So just as an example again, a drawing of a protective housing. So what is critical to quality? Well, if I'm purchasing a protective housing from one of my suppliers, I probably provided a drawing. And on that drawing, I may specify what items are critical to quality. I may want my supplier to inspect all the dimensions. I might put more emphasis on certain dimensions. And when I'm receiving that material, if I have a confidence level in my supplier, I may only verify a few items that are critical to quality that I'm going to verify at incoming inspection. This is a balancing act between you and your supplier, the criticality of the component, your confidence level in your supplier, and what is stated in your quality assurance program. So another drawing is an example. This one is a pretty busy welding symbol. If some of you might be familiar, you see that this is a diagram and a welding symbol for a nozzle and a reinforcing pad to be welded into a tank. You're probably not going to get that specifically from incoming inspection, but I wanted to use it as an example of components that you may purchase. You may not just be purchasing something as simple as a fastener. You purchase something like a safety valve. The norm for years has been receiving that certificate of test, and maybe that's all you're concerned about. Probably should be more. But when you're purchasing something manufactured, an assembly that might be rolled, welded, bent, machined, drilled, whatever it might be, you might have drawings with a lot of information on it like this. And you're going to want your supplier to understand what you need from them, what items are critical to quality, what you may want documentation verification of, and then of course, what you're going to inspect that's key and critical during your incoming inspection process. Go back to fasteners again. You know, I keep talking about bolts, but it could be nuts, bolts, screws, washers, pins, keys, clips, whatever you might purchase for the scope of work that you do as a certified facility. Each of those types of fasteners may have their own standard, their own acceptance criteria. Although if you go back and look at an ASTM standard, for example, you might not specifically see something labeled critical to quality. So that might be something that you have to determine yourself in conjunction with your supplier and possibly in conjunction with your end customer, depending on what that item is and what the specifications or criteria are. So let's talk a little bit about an inspection procedure, an incoming inspection procedure. So typically the procedure should describe the items to be inspected, what the CTQ characteristics are that are going to be verified during your incoming inspection process, the quantity of items to be inspected, could be a sampling plan, excuse me, the acceptance criteria, and so that acceptance criteria should be specified directly in your procedure, or in some cases where there's acceptance criteria based on industry standards, your procedure may refer directly to those industry standards for the acceptance criteria. And then, of course, disposition of non-conforming items. And for that matter, disposition of conforming items. I receive a material, I inspect it, it passes the acceptance criteria, now what do I do with it? And the same thing for non-conforming items. I have identified an item that's non-conforming, what do I do with it? How do I keep it out of my system? What's the next step? And these are all things that should be addressed already through your quality assurance manual and your quality assurance program. And your procedure could identify and describe more items. This is just an example of some of the things that are going to be related directly to key characteristics. So a detailed report may be beneficial. I probably feel that a lot of you are now grumbling and mumbling because that's probably not a typical part of an incoming inspection procedure. I've seen different levels of documentation for incoming inspection. Something as simple as initial and date a line item on a packing slip or purchase order, okay to some degree, or something as elaborate as this where now that we're identifying critical to quality characteristics and those associated acceptance criteria, how are we going to document that we are indeed performing that inspection and acceptance or rejection of the product? An inspection report more detailed than what we typically see today might be part of the upcoming process. But again, that's up to each facility to determine under their own quality assurance program. So a good way to document incoming inspection is with an inspection checklist. This helps the inspector know what items are critical to the part, and depending on how you want to put your program together, you may have a generalized inspection report, you may have an inspection report or checklist for specific components or specific categories of components. Again, just some ideas to think about. It's still up to, the responsibility is still up to the facility to determine how your quality program is going to work in conjunction with CTQs. And this is just an excerpt of a procedure that we came across. You'll see that it's labeled level 1 up in the top here. So you might want to categorize different groups of components to different inspection levels, for example, level 1, level 2, level 3, and then identify those components and the types of things that have to be inspected for those components. Now, in this particular case, this is really identifying the markings for service equipment, if you can see there under paragraph 1.1. And for a pressure relief device, I have to check the OEM, the model number, the serial number, the pressure, flow capacity, the flow rating, et cetera. So those items there might be what I've determined is critical to quality for a pressure relief device, and those are the items that I'm going to inspect during my incoming inspection process. Level 2 might be a group of materials categorized to a lesser rigor of inspection depending on the criticality of that component, or even depending on your confidence level of your supplier. And I may have a sampling plan for those materials versus 100% inspection for other components. I might have an inspection control plan, something that's going to identify the type of material that I'm inspecting, what are the requirements, where do they come from for my inspection process, what equipment am I going to need or use for that particular inspection, my sampling size or frequency, and then who's responsible. Since today we're talking about incoming inspection, it's going to be the incoming inspector for the most part, but is it also going to be your supplier? And if you're relying on your supplier to inspect and confirm key characteristic acceptance criteria, key characteristics according to acceptance criteria, then you might want to identify that in your procedure or in some other documentation. And we'll talk a little bit more about that coming up as well. And so our next part, we're talking about supplier expectations. And so I'm going to let Jim Donnell talk about that a little bit more. So, Jim.
Good morning, everybody. This is Jim Donnell. I just talk real briefly about supplier expectations. RSI, which is Railway Supply Institute, is working on a standard. It's called RSI 100, Product Quality Certification. RSI has been working on that for the last year or so, and it's changed over the last several months with changes within the industry. But and the RSI 100 has been being headed up by John Byrne. It's a future standard that will make available the fundamentals of a product certification, as a means of providing confidence that a product acquired from tank car component manufacturers facilities, certified or non-certified, conform to a defined condition or capability. RSI is a formal, supplier product certification process that enhances, the requirements that are established in Chapter 2.9 of M1003, which is purchasing and contracting. And it's also equivalent a level of safety is required in 179.7. This will be accomplished by establishing a system to maintain supplier conformance, assess activities such as those outlined in an inspection and test plan, identify critical to quality characteristics. That's why we included that in here today, of tank car components, surface equipment, primary closures, mechanical fasteners, elastomeric sealing products, and a host of other things. It's going to come up with some product certification plans that are going to look at things like securements, machine components, machine welded components, castings, forgings, valve assembly, instruments, sealing components, and so you'll have product certification plans based off the criticality of the part or component. And it says here we anticipate the standard be available for public use by September. Well, with the COVID-19 situation, we're going to probably end up putting that off. If you want any more information on that, I would recommend you contact John Byrne. But it's going to be a very good standard of how you can audit your supplier and to verify those critical to quality components and characteristics are being addressed.
Thanks, Jim. Okay, so let's talk a little bit more about documentation of the CTQ criteria. Not necessarily the incoming inspection procedure itself, but identification and documentation of those items that you deem critical to quality. And let me just kind of recap a little bit about how we got to this point. So obviously a certified facility follows the quality program specified in M1003. M1003 2.5.2.2 says, identify the characteristics, and that's the key word here, to be inspected, examined, and tested at each point, and specify acceptance criteria to be used. Then in 2.10, incoming inspection, 2.10.1 says, inspect, test, and identify incoming items as required by the inspection and test plans. Okay, so 2.10.1 doesn't use the term characteristics, but it does refer back to the inspection and test plan, which does use the term characteristics and have direction and instruction there for the facility. And again, to recap characteristic, the definition from Chapter 1, M1003, is a unique attribute essential or critical to quality. So that's how we're tying this all together. Your production inspection and test plan has to identify characteristics and acceptance criteria. During incoming inspection, you have to follow your inspection and test plans, right? So as a facility, if you're responsible for your quality manual and your quality program, these are the things that your program should address, both in your manual and, if necessary, in supporting procedures. So it says I have to identify those characteristics. Well, where am I going to identify those characteristics at? That may be a spreadsheet, for example, separate from an incoming inspection procedure, but I may have something like a spreadsheet or some other documentation that identifies the items that I receive, that I purchase, related to the activity codes and scope of work for your facility, of course. And then I might identify for each of those items or components, I might identify what the critical to quality characteristics are for each of those components. So now that I've done that, I take it to the next step and I say, well, am I going to identify those key characteristics as part of my incoming inspection process, or am I going to require my supplier to verify those key characteristics and confirm to me that those characteristics have been met, right? So as a facility, you're still responsible to identify the characteristics, even if those characteristics are going to be verified and confirmed by your supplier. That's the way it's written and stated in M1003. So just in summary, critical to quality, CTQ, is an overall commitment with the facility and the supplier. The responsibility is on the certified facility. There are many ways to accomplish CTQ implementation. We just talked about, some examples and ideas today. If you see things differently, you can certainly apply different ways to implement CTQ verification within your own program. And how your quality program addresses CTQs for incoming inspection is a company decision that should be referenced in your own inspection and test plan. So thank you. I know that we probably ran on a little bit today, but I think we covered a lot of good information. Is there any questions? And if I'll hand it back to Chris.
Yep, we have a handful of questions here. Anyway, first off, thank you, Dave. Thank you, Jim. That was very good. All right, first question. How would a certified facility verify critical to quality attributes when a supplier will not supply a drawing or even let you know what grade of fasteners to use?
So, one more time, Chris, thank you.
Yeah, of course. How would a certified facility verify critical to quality attributes when a supplier will not supply a drawing or even let you know what grade of fasteners to use?
Really, you as a purchaser would have to stipulate what are your critical quality to your supplier.
And so if you're receiving a component with multiple parts, right? Sounds like you have, fasteners within the component itself. So depending on the complexity of the component, the design of the component, that I could see that question. There might be some issues on how, as a facility, how am I going to identify what's critical to quality? Well, there's a couple of things there, and I'll just use valve for an example. So if I'm purchasing a valve, I may not be given the design drawings from the valve manufacturer, but I want confirmation and maybe verification and certification from the valve manufacturer that, one, they're manufacturing that valve according to their own design requirements. And in the case of a valve, and this is why I go with valve because it's kind of easy, I want to verify that that valve is approved by the AAR and that the manufacturer, in this case, is complying with their own design requirements. So if that's the case, I may not know about each and every component of that valve, but I do know that for the valve as a whole, that the supplier is verifying and certifying that that valve meets requirements. Now, I may add on to that now what my own requirements are. I receive a valve or some similar type of component, and I may want to look at things like overall visual inspection. Is the tag applied securely? Does the tag have the proper information, et cetera? So I hope that answers the question in some degree.
Yeah, in your first bullet point of your summary, Dave, critical quality is
going the wrong way. There we go.
It's an overall commitment with the facility and the supplier. So you have to work in conjunction with your supplier to help you with those critical quality items.
Looking for another question?
There was a follow-up to that question. We're going to get back to that one. There's a few more questions, and then we'll get back to that response. Who at my company is responsible to determine critical to quality characteristics?
Okay, so that's a good question. So who at my company is responsible to identify key characteristics? Well, that's really going to depend on your company structure, maybe how you write this, if you haven't already, into your QA program. But M1003, for example, doesn't say who at a facility has to identify key characteristics. It just says that they do have to be identified. So, within your own management system, somebody with knowledge and experience makes sense. But you may also need to go back to your suppliers and your customers to determine what items are critical to quality. But no specific person is really identified as who has to do that. Could be the QA manager, could be somebody at a higher level, could be somebody at a lower level. Really needs to be somebody with knowledge and experience.
Right. Do I need a separate procedure?
Do I need a separate procedure? Okay, so let me address that and how I think the intent is. So, do I need a separate procedure for CTQs? You could. The M1003 doesn't specifically say that you have to have a procedure for characteristics that are critical to quality. In actuality, 2.10 incoming inspection does not reference a procedure. It references the inspection and test plan. However, again, my opinion, I see that an incoming inspection procedure is common and probably best practice and a good idea. And you might roll the identification and acceptance criteria of all your components for the CTQs into your incoming inspection procedure, or you might just have key characteristics of components identified in a separate procedure or document, and in your incoming inspection procedure, you may have what to inspect, how to inspect, and the acceptance criteria. So again, it depends on your own quality program, what best fits your needs and how you want to address it. Could be all in one procedure, could be separate procedure or documents. I think we have more questions. We're looking at those now.
Understanding characteristic is defined in M1003, and the term not used in elements 2.9 or 2.10. Why aren't my approved suppliers responsible to identify the characteristics to be inspected, examined, and tested for the material, product, or service provided?
Okay, so let me just repeat at least part of that question. Why aren't my suppliers responsible? Okay, that part of the question really sticks out at me. You know what? Your suppliers are responsible. They're as responsible as you make them, right? So under your quality program, you should be approving your suppliers. And the criteria that you approve those suppliers on, though, is really up to you in your own program. I mean, typically we can go back to some of the old adages, well, you know, cost, delivery time, that sort of thing. But certainly confidence level of the quality of the product receiving from your suppliers and working with your suppliers directly to identify key characteristics, what those acceptance criteria are going to be, understanding what your supplier's quality program is and how robust their program is, and relying on your supplier to perform their own verification of key characteristics and other characteristics as well. You know.
And I know an AER certified facility, if you're purchasing something from them, they are required for their suppliers. And that's when they get audited, they have CTQs and income inspection for their subcontracted items. So they're not absolved of it. They have their own responsibility for their suppliers.
So just to recap, yes, suppliers do have responsibility as much as you as a certified facility apply to them. And of course, as Jim said, if your supplier also happens to be an M1003 certified facility, this program, the quality program and CTQs apply to them as well. And as far as paragraphs 2.9 and 210, I'll talk about 2.10 real quick because we had some excerpts of that in our presentation. 2.10 doesn't use the term critical to quality, but it does refer you back to your inspection and test plan, which does use the term characteristics, which is defined as critical to quality. So that's the tie-in from 2.10 back to critical to quality.
Great. We do have a couple more questions, and I know it is at the hour, but we'll just try to get these last few in here. What are the differences in the requirements as applied to a manufacturer or service-based repair facility?
So obviously there's some difference when you're providing a physical component versus a service. Yet there still are items or processes that are critical to quality for each of those. So if I'm only providing a service, it's not necessarily something I can put a tape measure or a thread gauge on. But what are the expectations of my customer? And again, is my customer an internal customer or an external customer? And so if you're only providing a service, you may want to look at those items that are important to your customer, what's critical to their perception of quality, or what's critical to the functionality of the end result of the service that you're providing. So a lot of times for a lot of us that may be a little bit trickier to identify, but keep in mind that if I have a physical component, okay, I can measure something, I can gauge something, that seems fairly straightforward. You might have to think about that and get input from your customer when it comes to items that are critical to quality for services provided.
There is one more question. And if any other questions come in due to time, we can answer them after the fact. We can follow up in an email. Are there guidelines setting up a suitable sample size in which to inspect components? Yes, and I should know this off of the top of my head, but there is an ANSI standard that addresses sample size among other things, and I'm going to blame it on Jim. Do we know the number of that ANSI standard off? I know some of you out there know the number to that ANSI standard off the top of your head, but
I'll track that down for you, whoever asked that question. If you want to email me at ronzani@alltrans.tech.com, I will find that answer for you. But yes, there is certainly at least one, but I'm sure more than one standards out there that can be evaluated and used to help guide your program for a sampling plan.
All right, there is, like I said, that was the last question we had, and due to time, thank you, Dave and Jim, for doing that, and thank you everyone for attending. There will be a survey probably within an hour following the webinar, so please feel free to fill that out. Dave, Jim, any last words?
No, just make sure you fill out that survey, and any kind of subject you would like to talk in the future that would help us to understand what are some of your needs out there and to help you with that.
And that's it. Thanks everybody for joining. Appreciate you listening. Thanks for your questions. If you have more, please submit those and we'll try to follow up at the best we can. So enjoy the rest of your day.
Thank you.